Hello everyone. On this video we will be covering the chain rule for functions with several variables. Okay, so really it's just kind of a tweak from the chain rule that you learned from Calc 1. So if you remember from Calc 1, we have derivative of y with respect to x is equal to derivative of y with respect to u times derivative of u with respect to x, or derivative with respect to x of a composite function, so f of g of x is equal to f prime g of x times g prime of x. So again, your chain rule for your basic two-dimensional real valued function. Okay, so now we're going to look at our chain rule for one independent variable. Okay, so we have our chain rule for one independent variable. Okay, so what if we let w equal your f of xy, where f we know is differentiable, which means the first derivative exists. So f is a differentiable function of x and y. Okay? So now what if x and y are two functions of a variable? Okay? So what if x is equal to some function of t and y is equal to some function of t, where of course g and h are also differentiable? Differentiable functions of t. Okay. If that's the case, then w is a differentiable function of t and that differentiable formula is derivative of w with respect to t is equal to the partial derivative of w with respect to x times dx dt plus partial of w with respect to y times dy dt. Okay, so this is your chain rule formula when you have one independent variable, and that's t. Okay, so quick proof. Okay, now we know that g and h are differentiable. Okay, so since they're differentiable, we know that their delta x and delta y at some point approaches 0 as delta t would approach 0. Okay, so since g and h are differentiable, we know that delta x and delta y approaches 0 as delta t approaches 0. Okay, so if that's the case, we know that our delta w is equal to partial w with respect to x, delta x, plus partial w with respect to y, delta y, plus our error of delta x plus our error of delta y. But we already know simply by definition that E1 and epsilon 2, they both approach 0 as delta x, delta y approaches 0. All right. So as long as we know that your delta t is not equal to 0, so we know that if your delta t doesn't equal 0, then we can divide each of those terms by that delta t. We have delta x over delta t plus partial w with respect to y, delta y over delta t, plus your epsilon 1, delta x over delta t, plus your epsilon 2, delta y over delta t. Okay. Now your epsilon values are usually there to calculate for error, but we're going to assume that we're looking for the exact value since we are. So they both equal 0. Okay, so by definition, derivative of w with respect to t is equal to the limit of delta w over delta t as delta t approaches 0, which is equal to partial w with respect to x. You have your dx dt plus partial w with respect to y, dy dt. Which is the formula that we have there. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and jump to our first example. All right, so let's say, for example, we want to find our derivative of w with respect to t using the chain rule for w equals x squared plus y squared, where x is equal to e to the power of t, and y is equal to e to the power of negative t. So make sure this is focused. Okay. Okay. Now, before we get started, we know that we're going to need our partial w with respect to x, our derivative of x with respect to t, our partial w with respect to y, and our derivative of y with respect to t. All right, so calculating those, our partial w with respect to x Remember, this is our w here. So the partial derivative with respect to x, we know that y squared with respect to x, that's going to be just a constant. So the derivative of a constant is just 0. So that disappears. So the derivative of x squared is 2x. Okay. Now our dx dt, derivative of x with respect to t, derivative of e to the power of t is just e to the power of t. Partial of w with respect to y, we see here, with respect to y, that x squared is going to be 0. So our partial of w with respect to y is going to equal 2y. And derivative of y with respect to t is equal to, this is our y, so that will be negative e to the negative t. Okay, so we have everything that we're going to need. Okay, now once you have those 4 things, you just go ahead and plug them right into your formula. Derivative of w with respect to t is equal to partial of w with respect to x, dx dt, plus partial of w with respect to y, dy dt. Okay, so plugging everything in, that's going to equal partial of w with respect to x is 2x, dx dt, e to the power of t, plus partial of w with respect to y, 2y, and derivative of y with respect to t is negative e to the negative t. Okay, so that's going to equal 2x times e to the power of t. And since that's a negative, we can just make that a minus 2y e to the negative t. Or you can just factor out a 2, x e to the t minus y e to the negative t. Okay, so that would be your answer. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and go to our next example. Okay, so again, using the chain rule, we want to find our second derivative of w with respect to t when, let's say, w is equal to the arctangent of 2xy. Let's say that x equals cosine of t and y is equal to sine of t. And we want to know at the value of t equals 0. All right, so to solve this one, again, we're going to need our partial of w with respect to x. Okay, so in this case, and just a little bit of a reminder here, let me make that a little wider. Okay, that the derivative of arctangent of u is equal to u prime over 1 plus u squared. Okay, so the partial of w with derivative with respect to x, that's our w here. So our u is equal to 2xy. but we're looking for the partial derivative with respect to x. So if we factor out the 2y, the derivative of x with respect to x is just 1. So we end up with 2y over 1 plus 2xy squared is just 4x squared y squared. Okay. Now we need our dx dt. Derivative of x. So the derivative of cosine is just negative sine. We need our partial of w with respect to y. Okay. Again, we're going, that's our u. So the derivative of u with respect to y, the 2x is actually considered a constant. So that's just the derivative of y with respect to y, which is 1. So you have 1 times 2x over 1 plus 4x squared y squared. Okay. And then we just need our derivative of y with respect to t. So derivative of sine is just cosine. Okay, now plugging into our formula. Our derivative of w with respect to t. Remember that's the partial of w with respect to x times dx dt plus partial of w with respect to y times dy dt. All right, so we know that's going to equal partial of w with respect to x is 2y over 1 plus 4x squared y squared. Bring that down a little bit. Y over 1 plus 4x squared y squared times dx dt, which is negative sine of t, plus partial of w with respect to y is 2x over 1 plus 4x squared y squared. And dy dt, which is cosine of t. All right. Now, what we want to do here is replace our x and y. Okay. So we see here that x is equal to cosine of t and y is equal to sine t. Okay. So that's going to equal, instead of 2y, it's 2 sine of t over 1 plus 4 times sine squared, or cosine squared, sine squared. Times negative sine of t. Plus, we have 2x, so that's 2 times cosine of t. Over 1 plus 4 cosine squared, sine squared. Times cosine of t. Okay. So, since we're going to have a negative sine squared and a positive cosine squared, I'm just going to move this one up to the front. So we have 2 cosine squared t minus 2 sine squared t. Since the denominators are the same, we're just going to put them both over 1 plus 4 cosine squared t sine squared t. Oh, sorry about that. Okay, so that's your dw dt. Or if you want to factor out a 2, you can. Two cosine squared t minus sine squared t over 1 plus 4 cosine squared t sine squared t. Okay, so that's our first derivative. Now, if you notice, we don't need a special formula because the only independent variable we have is t. So we don't have to use a special formula. We just have to differentiate this with respect to t to find the second derivative. Okay, so let me just give that a little bit of room. Okay. Second derivative with respect to t. Okay. So we're going to have the denominator, which is 1 plus 4 cosine squared t sine squared t. So denominator times the derivative of the numerator. That's actually negative 8 cosine t sine t. Minus the numerator times the derivative of the denominator. So you have 2 cosine squared t minus 2 sine squared t times the derivative of the denominator is actually, I'm running out of room here, but this is times, I'm going to need more space. Because remember, this is being multiplied to this. Just ran out of room. So you have 8 cosine cubed t sine t minus 8 sine to the third of t cosine of t. And cover that up. There we go. Let me bring that minus out a little bit. There we go. Okay, so these two multiplied minus these two multiplied all over your denominator squared, which is 1 plus 4 cosine squared t sine, let me clean that up, squared t, and that is going to be squared. All right. So, if we distribute all of those terms and do the FOIL method on this side and combine like terms and cancel out things that are canceled out, we will end up with negative 8 cosine of t sine of t times 1 plus sine to the 4th power of t plus 2 cosine to the 4th power of t all over 1 plus 4 cosine squared of t sine squared of t squared. All right. So that's our second derivative. Now, if you want to find it at t equals 0, sine of 0 is just 0. So you have 0 times whatever this is, it's still going to be 0. So it's 0 over 1, which is still 0. All right. Now, if you're trying to figure out how I got the derivatives here, I actually worked those out earlier on the next page. So if you are done writing here and you want to see how I did the derivatives for the quotient rule, if you're still writing this, feel free to press pause, but I'm going to go ahead and bring that page up for you. All right, so these, when I did the differentiating on the previous example, this is how I worked it all out. So if you wanted to write this down, feel free to press pause and write this down. But if you're all done, we're going to go ahead and move on to our next section. Okay, now we're going to look at the chain rule for two independent variables. All right. So before we just had the independent variable of t. Okay, so what if we have more than one independent variable? Okay, so again, what if we let w equal some function f of x, y, where f is able to find the partial differential. Is a partial differentiable function of x and y. Okay, remember, those aren't the independent variables we're talking about. We're saying that if x is equal to some function g with the independent variables of s and t, and y is also equal to some function with two independent variables s and t. Remember, those are your two independent variables here. Okay. Such that we know that partial derivative of x with respect to s, partial derivative of x with respect to t, partial derivative of y with respect to s, and partial derivative of y with respect to t all exist. Okay, so if all of those exist, then partial of w with respect to s and the partial of w with respect to t are given by these two formulas. Partial of w with respect to s is equal to the partial of w with respect to x times the partial of x with respect to s plus the partial of w with respect to y times the partial of y with respect to s. Okay. And partial of w with respect to t equals partial of w with respect to x times the partial of x with respect to t plus partial of w with respect to y times the partial of y with respect to t. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and go to our next example. Draw my little we're done square. Okay, so for example, what if we wanted to find our partial of w with respect to s, and our partial of w with respect to t, kind of jumping ahead a little bit, for w equals x squared minus y squared, where we know that x is equal to s times cosine of t, and y is equal to s times sine of t at the point s equals 3 and t equals pi over 4. Okay. Now the s equals 3 and t equals pi over 4, we're going to do that at the very end. Okay. The first thing we got to worry about, finding those two. All right. So again, we know that w is equal to x squared minus y squared. X equals s times cosine of t, and y equals s times sine t. Just rewriting what we already have. Okay. Now, our partial of w with respect to x. Okay. You see here, that's our w. Partial with respect to x for y squared is just 0. So the partial with respect to x is just 2x. Okay. Now the partial of x with respect to s. X is s times cosine of t. So the partial with respect to s, remember the cosine of t is looked at as a constant, so that can be taken out to the front. So the partial with respect to s of s is just 1. So it's 1 times cosine of t, which is just cosine of t. Okay, so we have our partial of w with respect to y. Here, with respect to y, that x is considered a constant. So the partial with respect to y is negative 2y. Okay, and our partial y with respect to s, there's our y with respect to s. Remember that sine of t is considered a constant, so that moves out to the front. So the partial of s with respect to s is just 1. So it's 1 times sine of t, which is just sine of t. Okay, so we have everything we need for our partial of w with respect to s. Okay, so partial of w with respect to s is equal to partial of w with respect to x times the partial of x with respect to s plus partial of w with respect to y times the partial of y with respect to s. Okay, so we're just going to get each one of those, plug them in. Okay, so that's going to equal partial of w with respect to x is 2x. Partial of x with respect to s is cosine of t. Plus partial of w with respect to y is negative 2y. Times partial of y with respect to s is sine of t. Okay, so just like before, now that we have that, we're going to replace our x and y. And a little ampersand there, so just means x and y. Okay, so that's going to equal 2 times x. So remember, that's 2 times s cosine of t times cosine of t. We can say minus or plus -2, doesn't matter. Plus -2 times y. Remember, our y is s sine of t times sine of t. Okay, so you have 2s cosine squared of t minus 2s sine squared of t. So 2s cosine squared t minus 2s sine squared t. Okay, so if we want to factor out the 2s, we can. So that's 2s cosine squared of t minus sine squared of t, which we're going to put that as one nice, neat little term, which is 2s cosine 2t. Because cosine of 2t is equal to cosine squared of t minus sine squared of t. It's one of your trig identities. All right, now we're going to go for our partial of w with respect to t. Okay, so we need our partial of w with respect to x. Okay, again, our w is x squared minus y squared. Actually, we did that one already, so we can just use that again. But now we just need our partial of w with respect to t. I mean, partial of x with respect to t. Sorry about that. There we go. Okay, now our x is s cosine of t. Okay, now if we get that s and pull it out to the front, because that's considered a constant, derivative of cosine of t is negative sine of t. So that's going to equal negative s sine of t. Okay, we need our partial of w with respect to y, which we already figured out. We can use that again. Negative 2y. And we need our partial of y with respect to t. Okay, again, that's our y with respect to t, so that s is considered a constant. So the derivative of sine of t is cosine of t, so that's s times cosine of t. All right. So everything we need, partial w with respect to t equals partial w with respect to x times the partial of x with respect to t plus partial of w with respect to y times the partial of y with respect to t. Let me clean that x up a little bit there. There we go. Okay, so again, if once we plug everything in, partial of w with respect to x is 2x. Partial of x with respect to t is negative s times sine. Clean that up. There we go. Sine of t plus partial of w with respect to y is negative 2y times partial of y with respect to t is s cosine t. Okay, so just like before, we're going to go ahead and just simplify everything there after we replace our x and y. Okay, so we know that we have 2 times x. Remember that your x is s cosine of t. Times negative s sine of t plus negative 2, our y is s sine of t. So that's s times sine of t times s cosine of t. Okay, so this is all multiplied here, and this term is all multiplied there. So you have 2 times s times s. So you have negative 2 s squared. So negative 2 s squared. You have cosine of t, sine of t. Really, you have negative 2s squared for both of these. So if you factor negative 2s squared for both of those, that will leave you with 2 cosine of t sine of t. Because you have cosine times sine, cosine times sine. So it's just that added together. Okay. But we also know that 2 sine of t cosine of t is actually equal to sine of 2t. For your trig identities. Okay, so this is going to equal negative 2 s squared sine 2t. Okay, so we have our partial of w with respect to t and our partial of w with respect to s. All right, now we just have to find them for t, s equals 3 and t equals pi over 4. All right, so that won't take up much space. So at s equals 3 and t equals pi over 4, our partial of w with respect to s, which we know is 2 times s times cosine of 2t, is 2 times 3 times cosine t equals pi over 4. You'll get 2 pi over 4, which is pi over 2. Okay, so that cosine of pi over 2 is equal to 0. So 0 times 6 is just 0. Okay, and partial of w with respect to t is equal to negative 2 times s squared. So you have negative 2 times 3 squared times sine. Remember, you have 2 times pi over 4, so we have 2 pi over 4, which simplifies to pi over 2. Okay, so sine of pi over 2 is equal to 1. So you have 3 squared, which is 9. So you have negative 18 times 1, which is negative 18. Okay, so that is your answer. All right, so if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next section, which is probably the most straightforward of the chain rule formulas, and that's implicit differentiation. Okay, so starting off with the definition, what if we let the equation. This time we're going to use the uppercase F. Okay, normally this means integrals, but it doesn't in this case. It's just an uppercase F equals 0. Define y implicitly as a differentiable function of x. Then, this is the formula here, you have dy dx is equal to negative partial with respect to x over partial with respect to y, and that's assuming that the partial with respect to y does not equal 0. All right, so if they ask for implicit differentiation, this is the formula you'd use. Also, depending on how many independent variables you have, what if we let f of x, y, z equals 0? Define z implicitly as a differentiable function of x and y. Of x and y. All right. Now, if that's the case, then the partial of z with respect to x is going to equal negative partial of x over partial of z, and your partial of z with respect to y is going to equal the negative partial of y over partial of z. Of course, that's where we assume that your partial of z does not equal 0. All right, so if you are still writing, feel free to press pause. But we're going to go ahead and go to our examples. All right, let's say, for example, we wanted to differentiate implicitly to find the first partial derivative dy dx for x squared minus 3xy plus y squared minus 2x plus y minus 5 equals 0. Okay, so if you notice here, you only have two independent variables. You only have x and y. Okay, so only two independent variables. Okay, just a little something to notice. Okay, so really all we need is our partial with respect to x. Okay, so you know find the derivative with respect to x at each term. So this will give you 2x. Okay, the 3 and the y are considered constants. So the partial derivative of x is just 1. So 3y times 1 is 3y. And the partial with respect to x of negative 2x is just 2. These two will be considered constants, so they would equal 0. Okay, now the partial with respect to y, this would be considered a constant, so that would be 0. The 3x would be considered constant, so they move out to the front. The derivative of y is just 1, so that gives you negative 3x. Derivative of y squared is 2y, so plus 2y. And the derivative of y is just 1, so that's plus 1. And the derivative of a constant is just 0, so that just becomes 0. Okay. So now our dy dx is equal to negative partial of x partial with respect to y, okay, which will equal negative 2x minus 3y minus 2 over negative 3x plus 2y plus 1. And if you like, you can actually distribute the negative to either the numerator or denominator. We'll move it up top, so we'll have positive 3y minus 2x plus 2 over, say, 2y minus 3x plus 1. Doesn't matter which order you put them in. I just kind of move that to the front because they're positive. All right. So we have room to put another example on the same page. So we'll go ahead and do another example right below it. Okay, so what if we wanted to differentiate implicitly to find the first partial derivative of z for x squared plus y squared plus z squared equals 25. All right. Now, before you do anything, you have to remember f of xy has to equal 0, which means you just have to bring everything to the left side. So you have x squared plus y squared plus z squared minus 25 equals 0. All right, so we know that for f of xy, or z, well, not really z because you have z in here, but you have x squared plus y squared plus z squared equals 25. Okay, so the partial with respect to x is 2x, minus 25, sorry about that. Writing a little, there we go. So you have 2x. Partial with respect to y, 2y. The partial with respect to z is 2z. And that's all we would need there. So we just have to find our partial of z with respect to x and partial of z with respect to y. That's going to equal the negative of the partial of x over partial of z, which is negative 2x over 2y, which just becomes negative 2z, sorry about that, which becomes negative x over z. Okay, now our partial of z with respect to y is going to equal negative partial with respect to y over the partial with respect to z. Now that would equal negative 2y over 2z, which becomes negative y over z. All right. So once again, if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. All right, so for example, if we wanted to differentiate implicitly, got my L. To find the first partial derivative of w for if xyz plus xzw minus yzw plus w squared equals 5. All right, so just like before, remember your first step is remembering that your implicit function has to equal 0. Okay, which means that xyz plus xzw minus yzw plus w squared minus 5 equals 0. Okay, so that means that our xyzw, since you have those 4 variables, so f of x, y, z, w is equal to x, y, z plus x, z, w minus y, z, w plus w squared minus 5. All right, so we just have to find our partial of f with respect to x. Okay, so here the y and z are considered constants, so they'll go out to the front. Derivative of x is just 1, so 1 times yz is just y times z. Okay. Plus, again, the z and w are considered constants. That'll go out to the front. Derivative of x is just 1, so 1 times zw is just zw. There is no x here, so everything there is considered a constant. Derivative of a constant is 0, so that disappears. Same here, no x. Derivative of constant is 0, same here. So that's our partial with respect to x. Okay, so now our partial with respect to y, same thing. Here, the x and z are considered constants. So the derivative of y is 1, so that's 1 times x times z. Okay. There is no y here, so derivative of that would be derivative of a constant, which is 0. The z and the w are considered constants. They go up front. So you have derivative of y is 1, so you have 1 times zw. Okay, that would be a constant, and that would be a constant, so those are both 0. Okay, so now you have the partial of z. Okay, this z, the x and y is considered a constant, so they go out to the front. Derivative of z is just 1, so 1 times x times y is just xy. Same thing here, the x and w considered constants, so they go out to the front. Derivative of z is 1, so you have plus xw. So here, you notice the z, you have the y and w, they're both considered constants. They move out. So you end up with minus yw. No z here and here, so it's just the derivative of a constant. So there's 0. And we find our partial with respect to w. Here, those are all three considered constants. They disappear. Okay, the x and z considered constants. They move out front. Since the derivative of w is just 1. You have the y and z are considered constants. Derivative of w would be 1, so that's minus yz. Here you have the derivative of w squared, which is 2w. And the derivative of a constant is 0. Okay, so we have everything we need to find all of our first partial derivatives. Okay, so that means the partial of w with respect to x is equal to negative partial of x over partial of w. Okay, so that's going to equal negative partial of x is yz plus zw over partial of w, which is xz minus yz plus 2w. Okay, so next we have our partial y, partial of w with respect to y, okay, which is equal to negative partial y over partial w. Okay, hopefully you're starting to see the pattern of how these go. So if you have, with respect to x, you have the partial of x on top, w on the bottom. Partial of y, with respect to y, partial of y up top, with respect to w on the bottom. Okay, so that's going to equal negative our partial with respect to y, which is xz minus zw, or zx minus zw, doesn't matter, over our partial with respect to w, which is xz minus yz plus 2w. And last but not least, we have our partial of w with respect to z, which is the negative partial of z over partial of w, which is equal to the negative, our partial of z is xy plus xw minus yw all over xz minus yz plus 2w. Okay, and we are all done with that problem. Okay, so hopefully this video made sense, and I will see you on the next video.